So I'd love for you all to give a very, very warm welcome to Julie Gunderson.
Well, hi, everybody. First of all, what an amazing DevOps Days. So if we haven't already, I think we need to give a round of applause for the organizers and the volunteers that made all of this happen. Thank you, everybody. And also, I apologize if I sound like I've eaten a frog. I unfortunately got a little bit sick, so we will be burning this microphone at the end of my talk. There is some hand sanitizer. Yep, there you go. So I am Julie Gunderson. I am a DevOps advocate for PagerDuty. Just with a quick show of hands, how many people in here use PagerDuty? And how many people love to hate us? All right. Well, they're the ones that, allow me to come out here. So I just wanted to give them a little bit of a plug. But as mentioned, I am from Boise, Idaho. I put it up on a map here since people do tend to get it confused with Iowa and Ohio. And yes, we do have a ton of snow in Boise right now. I came from 30-degree weather to Raleigh. However, I'm from Boise, which is Les Bois, or the city of trees, and I'm pretty sure you have us all beat on your amount of trees. It's very beautiful here, my first time out here, so thank you for having me. Today, we are going to talk about the psychology of chaos engineering and the human factors to keep in mind. So I know we've heard a little bit about chaos engineering throughout the conference, so I hope this isn't too boring of a talk for you. But just, what are a few words, if people can shout out, that come to mind when you think of chaos engineering? Monkeys, okay. Any other words that come to mind when thinking of chaos engineering? Netflix, okay. Fantastic. So when we look at chaos engineering, it's the discipline of experimenting on a system in order to build confidence in the system's capability and to withstand turbulent conditions in production. So we've heard about monkeys, we've heard about Netflix, and this is oftentimes what comes to mind when we talk about chaos engineering. This little guy actually sits on my desk at home. I'm pretty sure he's a collector's item right now. So Netflix is the one that brought chaos engineering up. I know there's some differing opinions of where chaos engineering really started, but Chaos Monkey would go in. It was a tool that would go in and shut off services in production, and it really created this need for defensive coding because our systems are turbulent. It's not about if, it's about when. And now chaos engineering has morphed into something more than just shutting things off. It's really about experimentation. But let's go ahead and talk about what chaos engineering is not. So sometimes when I ask people what chaos engineering means to them, they say, well, all engineering is chaotic, right? Yes, engineering is chaotic, but that is not what chaos engineering is. It's not about being chaotic or our systems being unpredictable. There's a lot of work that we do in this industry and a lot of names that are unfortunate, such as chaos engineering, and we're going to talk about nomenclature later, but it's not meant to be taking chaos literally. Chaos engineering is not about breaking things. My coworker, Matt Stratton, actually put a tweet out there about what does chaos engineering mean to you? And Sylvia got her own slide. It's not about breaking things. Chaos engineering is not trying to figure out how are we going to make things fail. Chaos engineering is about experimentation. Chaos engineering is about creating a hypothesis. If you don't have a hypothesis, how are you going to know if your experiment worked? How are you going to learn from your experiment? Again, this isn't just about randomly turning things off and randomly breaking things. We have to have that hypothesis. Chaos engineering is an effective tool for learning in organizations today, and we talk about effective organizations being learning organizations. So, for example, at PagerDuty, we see incidents as a gift. Because as humans, we can't talk directly to our systems. We have to talk to them through a proxy. And when we have an incident, our systems are talking back to us and telling us what's going on. With chaos engineering, though, you get the ability to have your systems talk to you without having an incident. And that's what chaos engineering really is. It's a way to encourage our systems to talk to us so that we can learn more, so that we can have a hypothesis and test our hypothesis. So we talk about experimentation in production. And yes, it is preferred to experiment in production. And many people will tell you, you can only do chaos engineering if you do it in production. But that's not always the case, and we'll get into this a little bit later about what systems may not be best for being in production, because not everything is appropriate. Where production is preferred, and there's nothing like testing in production, and staging is not production. You don't have a Google bot crawling you in your staging. You don't have somebody trying to run your system on a 6-year-old Blu-ray player. We want to talk about still being able to do chaos engineering in those staging environments when it's not appropriate. And also, Charity Majors said something fantastic. She said, "Nines don't matter if your users aren't happy." And it's important to bring that up because in the world of scale that we live in, we talk about the 3 nines or the 4 nines or the 1s and the 0s, but we have to remember that there are still people, there are humans at the end of that system trying to do a thing. And we don't want to lose that because if they're not happy, then we've lost the entire goal. So it's better to control and better to understand our systems. And you can't do this without good measurement. So think about observability. When we're doing experiments, we have to be able to understand the impact of what we were doing. We need to be able to understand, when do we pull back this experiment? Maybe we hit a gate and it says this is too much because we have a hypothesis. But what happens when we test our hypothesis and it's false? What if our hypothesis is that if we shut down a particular system, the circuit breaker is going to just pop back on and people will be able to watch their movies again? What if they can't watch their movies? We have to be able to back out of our test. We have to be able to work around it. And we have to have an understanding of both what our system is like and what our user experience is like. So let's talk about minimizing our blast radius. So canary testing is one great way, one great technique when running chaos experiments. So just like we talked about running chaos experiments in production, it doesn't mean that you have to run these experiments against all of production. So we can kind of take a look at it like release. Microsoft has this great way that they do release. They do it within these kind of concentric circles. So first, they start out with their releases to the team that built it. And then they release out to the next group at Microsoft, and the next group, and then eventually all of Microsoft, and then the consumers. And all along the way, they're learning, and they're testing, and they're learning from their systems. So that's another way to look at chaos engineering and minimizing that blast radius. What if you started with just testing against 1% of production? And maybe you are testing against 1% of production because you have an idea. You kind of think you know what your hypothesis is, but you still need to formulate it more. So you test, okay, that worked out. Then you move on. You go deeper and you go further and further. That is one way to look at chaos engineering. So here's some helpful tools, which I think we actually saw in the previous talk. So we've got Netflix's Simian Army, which is on GitHub, and there's some great tools on there. Also Gremlin. Gremlin has both paid and free tools that you can use. They're really amazing tools. And then the Chaos Toolkit. But let's not forget about the people. The people on the other end of your tests, the people that you work with. We understand that following these techniques will help us understand our systems better, will help make our systems more reliable and more stable, and build more resiliency into our organization. And that's great. That's great for all the computers and the networks, but you have to keep the people in mind. So, how does it make you feel that Netflix is running chaos engineering in production? Is anybody, by a show of hands, who's happy about that? Okay? Who's sad about Netflix running? Okay? What about when it's your bank? There's a little bit of a difference with, we can't play this title right now, try again later, to trying to pay your rent, trying to transfer money into your account, not being able to access your bank. And that goes back to when we talk about maybe not all systems are best to do this in production. But does it mean that you shouldn't? Does it mean that there should be no chaos engineering because you're a financial services? No, you absolutely need chaos engineering. Again, you're practicing the hypothesis. You're teaching your organization how to fail gracefully, how to do retries. You're minimizing that blast radius. And again, you can start small, okay? You don't have to start your testing in production. For PagerDuty, we don't do all of our testing in production. We actually don't have maintenance windows at PagerDuty. And some of the things that we've learned is that maybe there are systems that we have that aren't reliable enough to do chaos testing in production. That may be something that you learn out of your chaos engineering practices. One of the best quotes I heard was from Bruce Wong, who is widely considered as the person who came up with chaos engineering at Netflix. Saying you're getting your systems ready for chaos engineering is like saying you're getting in shape to go to the gym. Right? So I don't think we get in shape to go to the gym. You might buy your shoes, probably a good idea, maybe your shorts and your shirts, but at the end of the day, you still actually have to go to the gym. So a lot of people are really nervous about chaos engineering, which is why if you need to start it in testing, okay. In staging, fine. But eventually, you need to put your shoes on, you need to put your shirt on, ideally, maybe your shorts too, and go to the gym and just jump in and try it. So knowing what all of you know about chaos engineering, by a show of hands, how many of you are reassured that a company or an organization uses chaos engineering practices? Okay, now how many of you are like, nope, I want nothing to do with it. It makes me unhappy. I will not use their product or service. All right, well, nobody showed their hands there, so that's fantastic. So we talked about nomenclature a little bit earlier. Management, they can get a little nervous. Nervous when you use words like chaos or failure. So you really want to think about using words like education, experiments, learning. Because when you're talking to your CFO, they may think you are intentionally injecting failure. So we may need to think about the words that we use. PagerDuty, we use failure Fridays. You could always use takedown Tuesdays. Alliteration is very important with all of this. However, your C-levels might not find it as funny. And then again, there's a mental and philosophical shift that needs to happen to embrace these types of techniques. It's not about just turning on Chaos Monkey. It's not just about employing these tools. You really need to consider the culture of the organization. And as we all know, you don't just snap your fingers. Culture doesn't change overnight. Culture doesn't change in a year, but culture starts with the individuals. And one way to impact culture is through behavior. So look at ways to incentivize people and incentivize behavior to embrace chaos engineering and chaos engineering techniques. How can you get people to participate? Now, here's a great tweet from Cody. This is a great example. They felt excitement over a new error that an intern found. One great way to kind of employ chaos engineering is to give junior developers and interns more freedom to do things and to get involved. And this isn't because they just break things, right? It's because they have a different way of looking at it. We may have been doing this for 10 years. We have been doing these tests over and over and over again. And here comes somebody new and fresh that may ask different questions, that may think differently than you and I do. Give them more of an opportunity to, well, break things, even though it's not just about breaking things, because it's going to give you a different way of looking at things. Also, safety first. Again, minimize that impact for your end user. Look at that blast radius. Think about what the impact is. And you do that by knowing your conditions. When are you going to shut down your experiment? So since everybody knows a lot about Netflix here, what is Netflix's key metrics that they look at? Does anybody know? Well, number of stream starts per minute, right? So when Netflix, everything else could be broken, but as long as their stream starts are where they should be, it's going to be fine. When that stream starts going down, that's when they look at backing out of their experiment. Know your conditions. Also, don't have 15 different metrics. That's not a well-formed experiment. You need to have simple key metrics that you're testing against. Also, this is not about causing stress on your people. We actually just did a chaos workshop at PagerDuty Summit last week. And there were some people at the table and we were talking about how do you get people to adopt this? And one person said, well, don't tell them. Right? Not the best way to build a safe environment to get people's buy-in. Also, you certainly don't want something to go down and for Kim to say, well, George, just shut it off. It'll be fine in a minute. That's not the way to do it. You want to make sure your on-call knows that you're running these experiments. You want your incident response team to know that you're running experiments. You want your executive leadership to know that you're running these experiments. Communicate. Be transparent. And remember, there are humans on the other end of those numbers. There is somebody that is trying to use your product. There is somebody that may be trying to pay for your product. There may not be very many of them, but they could be having a really bad day. So never lose sight of your customer, of your end user. And also remember, your coworkers are human too. You're shutting stuff off. You may be impacting them. So let's have some empathy and keep in mind who is important. For further reading, there's Chaos Engineering Traps by Nora Jones. She's over at Slack and she talks about things to watch out for as you're doing this work. At PagerDuty, we use Chaos Cat, which unfortunately we're not able to open source given how it works in our system, but Eric Ziegler wrote a great blog about automating fault injection. And then Optum, a United Healthcare group, actually open sourced a tool called Chaos Slinger about running chaos experiments in security-related environments. So that's another great tool. And then one other thing that you can do to help people at your organization become more familiar with chaos engineering, you can do chaos workshops. You can do tabletop thought experiments with people and teams in your organization where you really just have a quick, simple architecture, and you take a moment to think through what are the problems that we could face? How do we communicate these problems? How do we remediate these problems? We do retrospectives on those. So chaos workshops and tabletop experiments are another great way to look at chaos engineering. And with that, I'd like to open it up for any questions that you may have. All right, so everybody's going to go back to work and do some chaos engineering? Thank you all for your time.